All right, y'all, here's what we got going on today. We're going to be building a couple of projects, is what you guys are going to be doing. You're going to be building project number 6, which is the light theremin. And this is kind of a speaker or a buzzer that is controlled, its tone or its pitch is controlled by the ambient light that you might have. And we're also going to build a keyboard instrument, which is using also a little buzzer or piezo speaker to play different tones, right, based on buttons that you press, kind of like a little keyboard. So a couple of fun projects from the Arduino book, kind of working on that and practicing the coding and building things out. We'll talk about a few of the things and the trials and tribulations that you guys could encounter and things to be aware of. I'm also just going to talk about some of the pieces that are involved in these projects. Okay, so like a photoresistor, this idea of a voltage divider, which is a big deal. A piezo buzzer, what that is, while loops. We're going to introduce while loops. All right, so one thing I want you guys to be aware of is as we're introducing more and more of these projects, I'm trying to do a couple of things. Number one, I'm trying to introduce you guys to some different sensors, as well as some different kind of outputs that we can have. So in this case, we got a new sensor, which is the photoresistor, and we have a new output, which is the piezo, and also some different pieces of code that you guys can use, right? So introducing different ways to use variables, different ways to like tie things together, different kind of like full-on commands, like the while command is a totally new one. This tone command is very new. So just so you guys can build kind of your repertoire and your familiarity and also get some practice with using this. Once again, like the big thing that we're trying to do with all this is that you guys could eventually take some kind of like a challenge or a project and you guys could actually design something like a machine or a system that you could then code to actually like respond, sense its environment, and accomplish some kind of a task, right, in an automated function where you don't have a person that's always like watching it, but it's actually kind of thinking for and doing some of these things on its own. So that's the goal. So hopping right into it. This is kind of the project that you guys are doing, is this light theremin. It's kind of cool. Read through the book. It does a pretty good job of like walking through things if you just kind of take the time and go through it. So definitely kind of check that out and read through it. It's got all sorts of good stuff. But this is what you're going to end up with, right? Is it should look something like this, pretty straightforward. The piezo buzzer, which if we go in here, right, that is right there, right down under the basics still. And then we also have our photoresistor right there, right? So that's where you can find those bad boys. And then if we pull up our code, this is kind of what it looks like. So, and if you guys need to kind of look at that, there you go. There's your kind of look. If you guys ever need to pause that and kind of like go off of what I wrote. So here's our little photoresistor. Here's our piezo buzzer. We got our power and our ground. This is actually pretty straightforward. The main components that we have, we've got this photoresistor right there. And this is actually what they look like in real life. This is one kind of for scale on a breadboard. So they're not super big. They're these tiny little things. But what it is essentially this little strip, and it's a semiconductor that's doped. So it's kind of similar to a solar panel in some ways. But essentially what happens is when it is exposed to light, it becomes it has a low resistance, right, to the current. Current is coming in one side, and then it's coming out the other side. And when it's exposed to light, it has a low resistance, right? There's not a lot of resistance. It's somewhere in like hundreds of ohms. But when there's no light, when it's totally dark, it has a pretty high resistance, right? Somewhere in like the like millions of ohms, right? So depending on that, we have a variable resistor based on the amount of sunlight or the amount of light that's actually hitting it, right? And so that's how we could actually use this to sense how much light is coming into an area. So that's what that is. And on our circuit here, we kind of have, and we did this for our, which project did we have that with? I think we had that with our button, I believe. It's one of the things. In any case, you'll see a lot of times something like this where you have, when things like this have these two pins, right? When they have these two pins, you'll have power coming in one side and then another path to ground on the other. But then somewhere in between, right, you'll have this connection that goes to one of our analog sensors, right, to one of our sensing pins, or input pin. And this system right here is what we'd call a voltage divider. And this is a very key thing to kind of understand what's actually happening as to how this allows us to read kind of how much light is hitting this, right? So what that kind of looks like is this is kind of a diagram of what we have. We have our 5-volt kind of source, right, which is right here. And it's going through the photoresistor, which is our resistor 1. Or sorry, it's going through, we'll kind of do it backwards. kind of rearrange the order. Well, we're so it's going through the resistor first and then the photoresistor. This guy's in between, right? So that's kind of the route that it's taking. But we have our photoresistor, our variable resistor, our permanent resistor, our ground, our power, and then we have this kind of in between, this output. Right? And so what essentially happens is this divides the voltage. So if our Arduino could measure and read resistances, then this wouldn't really be a big deal, right? But it can really only read voltages, and it can kind of read voltages relative to like some kind of a baseline that it's receiving, right? So here, if we look at this, let's say that our photoresistor here is not providing any resistance. Let's say that it's totally dark and this is providing essentially 0 resistance, right? Well, then we have 5 volts here. It goes through here, and then this is 0 volts, the ground, right? So we'd have 5 volts, 0 volts. So that means that this output would be reading 0 volts, right? So then that's like a reading, right? That would essentially equate to, you know, our analog inputs go between 0 and 1023, so that'd be a reading of 0, right? But here, right, let's say that this is now it's got an extremely high resistance, right? Like or sorry, let's say, you know, in the first case, the lights are on, so it's low resistance. Now let's say it's dark, so it's got a very, very high resistance, right? Well, that means that we have one pathway with 2 resistors in series, right? 2 resistors in series. So as we know, when we have resistors in series, that voltage drops a little bit across each resistor, and it drops proportional to the amount of resistance being offered, right? So here, this is offering 5.6 kilo ohms resistance. Here, let's say this is offering like 1,000 kilo ohms of resistance, right? Well, that means that way more voltage is going to be dropping across here than it is here, right? So this might drop maybe 0.5 volts, whereas this is dropping 4.5 volts. Well, what's the voltage that this pin here is going to be reading? Well, it's going to be reading 4.5 volts, right? Because this is only going to drop a half volt. This is going to drop 4.5, so this is going to be reading 4.5. Whereas when this had no resistance or very, very little resistance, then 5 volts dropped here, so this was reading 0 volts, right? So now all of a sudden that pin that is going right to here, right, is able to read a variety of different voltages coming in. And for the reference, a potentiometer works just the same way, right? A potentiometer, it has the input pin, it has the ground pin, and then it has that slider, that dial. And that kind of changes the resistance. So it's the same kind of thing. It essentially splits this resistor in two, right, in differing amounts. So very similar to this, right? We have 2 resistors with this output in between, right? So a potentiometer, a temperature sensor, these are all forms of voltage dividers, right? So it all does this thing where it essentially allows us to read an analog input. So that's all that we have going on here is we're just dividing that voltage. Okay, so we've got our photoresistor, we have our voltage divider system to where we can actually measure, right, essentially the voltage drop that we're getting because of this. And so we can read essentially how much light is coming in. And then we have our piezo buzzer. Now, I kind of linked a video there talking about kind of piezo buzzers and how they work. But essentially, if you guys remember about piezoelectricity, if we squeeze a crystal, we can develop a voltage, certain crystals, right, like quartz crystals that are cut a certain way. And if we run a voltage across those quartz crystals, then they'll vibrate. Right? And when they vibrate, they can actually create a buzzing sound. Okay, so that's how this guy actually works. And if you guys want to check out that video again, you're more than welcome to. So here's how it essentially works. If we want to have this buzzer, right, sound a different tone based on how light or how dark it is, right? Well, let's think about what our how to have our tone change with light, what our flowchart might look like. Well, we're going to start. We're going to maybe read the light value that's actually coming in. We're going to record a high and a low value. So we're going to set a range. We're going to map that range of light values that we're getting to our desired value of tone ranges. And then we're going to read the light value again and then play a tone based on the light value. Now, this whole section right here, right, what we're doing here is we're actually calibrating. So this is our calibration. We're going to calibrate because we want to know, you know, what is our range of light values that we're actually going to get, right? What is the range of voltages that we're going to get from this? Because of the way this voltage divider works, we're not going to be able to actually get a voltage of 0 or a voltage of, you know, that reading of 1023. So we're going to get somewhere in between depending on the lighting that's actually there. So we actually need to calibrate it. And then it's a pretty simple, straightforward kind of system. So looking at our code, right, we have our sensor value, which is what's reading, what's the reading on the pin here at A0 from our light sensor. Then we have what's called sensor low, which is kind of the low value of the sensor. We have sensor high, which is going to be the highest value of the sensor, right? So the most bright and the lowest light. Then we have our LED pin. Now this is pin 13. Now you'll notice I don't actually have an LED on my system here. And that's because pin 13 actually has this internal LED, which is this little guy right there that we can actually control on pin 13. So we can actually control and use an LED for testing without actually putting it together. So that's what's going on there. So what we're doing is in this, we're going to turn on that LED, right? And then we're going to calibrate. So this is all in the setup. So this is going to run once, and we're going to use this while loop, right? Now, so this is going to say while the milliseconds, or while the time is less than 5,000. So less than 5,000 milliseconds. So for the first 5 seconds, right, what we're going to do is we're going to say that sensor value is going to be whatever we're reading at that pin. And if the sensor value is greater than 0, right, we're going to set that as whatever value it is, if it's ever that. If it's ever less than this 1023, we're going to set that as our low sensor value. So when we run this, we're going to set up like what is the most light and what is the least light, right? So what we're going to do is when we actually run this, one of the things we need to do is in these first 5 seconds, right, we need to select on this, and we need to, and this, by the way, you can see how slow it's running there, right? It's just finally reaching 1 second now, right? So that's one of the things is with these programs versus real life, it does run a little bit slower, but I need to go from the lowest values to the highest values, right? So for the calibration, right, it knows what is low and what is high. If you don't do this, it won't really work properly, right? Or it'll have a different calibration, right? You could have gone from there to there and never gone past that. And with ambient light, when you're actually doing this, it is true. Like ambient light may not be able to get this bright, right? You may not, in covering with your hand, you may not be able to get it this dark, right? But that's something that we need to do. And then once it actually starts going there, make sure I turn those down. Then as I turn this on, right, we should start to actually get a tone playing, right? And that tone will vary based on where I set the dial at. And it's actually kind of cool, kind of fun to mess around with. So once we set that calibration, we get that range of values, and it's pretty straightforward, right? We turn the LED pin off after those 5 seconds are over, and that just ran through once, right, for those first 5 seconds, while the time, right, was under 5,000 milliseconds, so 5 seconds. And then we're going to start our loop, and the sensor value is going to be analog read 0, and we're going to set a pitch, right? And the pitch is the frequency, right, that we choose. Now, it's going to say map, and then the sensor value from, that's our value, our range of values, and we're going to go from sensor low to sensor high, so whatever that ends up being. In my case, since I slid it all the way, it was from 0 to 1023. And then that's going to go from, and you can set this range, right? This is the range of pitches. Now, 31 hertz is the lowest that this piezo speaker can actually run on, right? But it can go up to like 4,000 or more. It starts at 4,000, it gets really high. So I actually moved mine down to 300. So I got like a more natural range of pitches. And then you're going to play it for 20 milliseconds. So you're going to play, so you that's where you set the values here. So we map those ranges there, right, using this map function. And then we're going to play the tone, right? For 20 milliseconds, we're going to play out of pin 8 here. We're going to use the tone function. And you set the pin, you set the number of the tone, the frequency in hertz that you want, and you set the time, right? So now pitch, I created this variable, and so that's what's been mapped based on what I'm getting with my sensor here. So depending on how bright it is, I'm going to get a different pitch, and I'm going to get a different number there. Right? And then you wait for a little bit, and then it reads again, and then it starts over. And so that's essentially doing this: read light value, play the tone, read light value, play the tone. And that's what's going on in our loop there, right? So yeah, that's that. That's all there is to it. It's pretty straightforward, kind of cool. It'd be a lot more fun in real life, but it's a few valuable things that you guys kind of learn how to manipulate. So that's that one piece. And the second project that I'm going to have you guys do is just this keyboard instrument, which is building on a lot of the same things. We still have this piezo speaker, right, coming out of pin 8. We still have a sensor reading at a 0. The only thing that's different here really is that our voltage divider, instead of being like a potentiometer or a temperature sensor or a photoresistor, what we have is we have this series of buttons, right? And these buttons, essentially, depending on which one I press, it will essentially give you a different voltage reading in a different range. So if we just kind of follow what's going on here, I have from my positive, right, through to here. If I press this button, right, well, then it goes from the positive straight down to here, to there, to there, to there, to there, to there, to there, straight to the pin, right? So this pin would be getting all 5 volts, right? So it'd be reading 1023 would be the value that it's going to be reading. Okay, if I press on this one, right, well, then all of a sudden it's going from here through this resistor to the pin and then over, right? So it's getting a certain amount of resistance, meaning that a certain amount of voltage is dropping here, a certain amount of voltage is dropping when it goes back down to 0. So it's going to read a certain amount, right, going back. If I press this one, it's the same, right? All these resistors are actually different, right? 220 ohm, 10 kilo ohm, and then 1 mega ohm, right? So depending on which one I press, it's going to open up a different pathway, and I'm going to get a different kind of division of voltages across. It's just a different kind of voltage divider. All right, and then what I have here and what I'm doing is I'm essentially saying, hey, you know, if these voltages are between these ranges, then I want you to play this frequency. Now, the one thing that this code does, and that they have you do in the book, is they have you mess around with another command called an array, right? Now, you don't actually need to do this. It's not totally necessary. You certainly can, and it's a cool kind of thing. It's useful when you're working with a large kind of series of numbers. Here are the frequencies that I want for the certain pitches, for the certain sounds I want on my keyboard, right? Which, if you know anything about music, it's like those frequencies tie to certain notes, right? In this case, it happens to be middle C, D, E, and F, right? Middle C, middle D, middle E, and middle F. Right, so I'm actually getting my notes that I want to play. Those are the frequencies for those notes. And so I'm creating a variable, an integer called notes, and these are the 4. And so this is essentially then it can play note 0, note 1, 2, and 3. So this would be 0, 1, 2, and 3. Now what I could do, right, is I could just type in here instead of note 0, I just want it to play a tone that I'm going to say play 262, right? Here I want it to play, instead of just notes 1, I want it to play 294, right? Similarly here, I could say 330. And here I want it to go ahead and play 349. Right. Otherwise, no tone. And then I could totally and completely take out this piece here, and it's actually not even necessary. And it should still work just fine. I could play. And you'll notice it kind of does this weird thing, but it's pretty cool. It's still fun. It'd be really fun to mess around with in real life, right? But so I don't actually need to do that array. I can just tell it which tone to do. But essentially, I use a bunch of if-else's. If that voltage is in this range, I want you to play this note. If it's in this range, I want you to play this note. So it's actually kind of a cool way to incorporate a lot of buttons. And you can make big keyboard. You can make like a full keyboard like this. So it's kind of cool. So a few projects messed around with this piezo with these voltage dividers. This one's voltage ladder, right? This one is working with a photoresistor. So a few new sensors, a few new things, a few new codes. This while command, very useful. We'll use that quite a few times. It can be very handy, especially if you want something to happen just while a certain condition is met, right? And then kind of stop. Okay, so mess around with that. Hope you guys have fun. Hope you're still enjoying it and staying safe and having fun out there. And I will see you guys later.